Good afternoon, everyone. Welcome to the Georgia Tech Manufacturing Institute's Lunch and Learn seminar series. My name is Ph.D. and I'm the Strategic Partners Officer for GTMI. GTMI is one of 10 Georgia Tech interdisciplinary research institutes that uniquely focuses on manufacturing research, development, and deployment. We tackle the grand challenges of today's manufacturers, and we help our partners move innovations from the lab to the marketplace. GTMI has a wide variety of facilities and equipment located on main campus for basic research and nearby for translational research on 14th Street for in the Advanced Manufacturing Pilot Facility, or AMPF. GTMI's mission includes education and workforce training, collaborative partnerships with industry, academia, and government, as well as thought leadership. GTMI hosts the Lunch and Learn series each fall and spring semester. Sessions are held every Monday at noon as live online events. These sessions are excellent opportunities for Georgia Tech faculty, students, and researchers, as well as our global manufacturing community to learn and share advanced manufacturing knowledge. To ensure a seamless presentation experience today, all audience members are muted. However, we would like to make the session as interactive as possible and encourage you to submit any questions or comments you may have throughout the lecture using either chat or the Q&A panel on your screen. And we'll reserve the end of the hour, roughly the last 15 minutes, to discuss any questions you may have with our featured speaker today. And today we are very pleased to host Georgia Tech alum Dr. Alaa, who is Assistant Director of the Technology Office of Advanced Manufacturing, National Institute of Standards and Technology, or NIST for short. And today's lecture is of special relevance to Georgia Tech, not only because of Dr. Elwany's status as an alum, but also due to the fact that Georgia Tech has an ongoing relationship with NIST and the Manufacturing USA Institutes, which Dr. Elwany helps to oversee. So Georgia Tech is a member of many of the Manufacturing USA Institutes, or MIIs, which Dr. Elwany will talk about later today. So Dr. Elwany is an ASME Foundation Swanson Fellow, serving as Assistant Director for Technology at the Office of Advanced Manufacturing, NIST. He supports the office on a range of topics and projects, including national policy for supply chain renewal and education and workforce development in advanced manufacturing. He is currently on detail from Texas A&M University, where he is a Mike and Sugar Barnes Career Development Faculty Fellow and Associate Professor at the Department of Industrial and Systems Engineering. Dr. Elwany acquired his Ph.D. from the H. Milton Stewart School of Industrial and Systems Engineering, Georgia Tech, and his MSc and BS in Production and Industrial Engineering from Alexandria University in 2002 and 2004, respectively. He was recognized with the SME Young Manufacturing Engineer Award 2017, the NSF Career Award 2019, ASME Challenge Trigger Young Manufacturing Engineer 2020, and ASEE Global Excellence Award for Industrial Engineering Education in 2020. His professional research interest is in the modeling, analysis, and control of advanced manufacturing processes with an emphasis on additive manufacturing processes. So at this time, I'm pleased to turn the mic over to Dr. Elwany to begin his presentation.
Thank you very much, Paige. You hear me okay?
Yes. Loud and clear.
Great, thank you. Good afternoon, everyone, and thank you so much for making the time to attend this seminar series. I would like to start by extending thanks to many people on this call, and I'll just say them as they come to my mind. Dr. Ben Wang, Dr. Shreyas Milkot from GTMI, and Dr. Billy D. Brown. Thanks for inviting me. Special thanks to my colleague and friend, Dr. Kamran Payanbar, for initiating this opportunity for me to return to my alma mater. And thank you also very much to Paige and Mir and everyone who was involved in facilitating this. So thank you very much. And with this, I start. And I'd like to talk to you today about manufacturing the future efforts in NIST that support that. And I would like to start the seminar with a quiz. You know, I cannot help but remember that I'm primarily an educator at Texas A&M. So I will start with a quiz, and I encourage you to use the chat function to try and answer this quiz, or if you have the capability to even unmute yourself and answer it. So please name prominent researchers in the following two pictures. Here is picture number one. Obviously, on the right is me 13 years and 10 pounds ago. And on the left is, any guesses? And I apologize because I'm not able to read the chat session, but I will assume that many of you have guessed that this is Dr. Nagy Gabriel, standing with his first PhD student on the day of right after defense back in June, if I remember, of 2009. That is in the Industrial and System Engineering department. And here's the continuation of the quiz. Two more prominent researchers who were on my committee. Anyone recognize those? I'm sure you do. And I also assume that some answers have been submitted. We have Professor Jan Shi over here to the right. We have Professor Chip White here to the left. And the Dr. Jeff Wu was also on my committee, and Dr. Lisa Maillard from Pittsburgh University. So I'm a proud Georgia Tech alumni, and just like Paige, thank you for the introduction page. Starting from Georgia Tech in Atlanta, Georgia, right after graduation, I took a faculty position at the Eindhoven University of Technology, which is one of the key 3 engineering programs in the Netherlands. 2011, due to personal family reasons, I had the need to return to the US and the desire to return to the US. So I returned in 2011 as a research scientist at General Motors Manufacturing Systems Research Laboratory. But it was great over here. I did lead a bunch of projects, had great achievements, but in 2013, my passion for academia started to kick in again. So in 2013, I returned to academia and took a faculty position at Texas A&M University, where I still am faculty member over there. And this took me to my current adventure, where I'm on detail at the National Institute of Standards and Technology, which I'm going to give an overview about. And for those of you who are curious, I'm at NIST on detail from Texas A&M as part of the ASME Congressional or Federal Fellowship Program. This is essentially a program that provides service opportunities for scientists from universities and outside of universities to contribute and provide input to policy makers in the US. So, we do have, I believe we do have multiple of current and previous ASME federal and congressional fellows at Georgia Tech. Off the top of my head, I know that Dr. Shreyas Milkot was actually assigned in the same office where I'm serving right now. And I encourage those of you who are not familiar with the program to check it out and try to participate. So when I was preparing today's talk, I was confused what exactly to present, because we talk to a very broad audience. We go out and talk with people ranging from legislators to federal employees to public communities to academic institutes, and obviously you talk with each of this set of audience with a very different mindset. So today I tried to tailor the topics that I described more towards an academic setting, hoping that many of the academic members who are attending today would benefit from this and find opportunities to involve. You will find me emphasizing, hey, how can you actually get involved? I don't just want to come and educate you about NIST. Of course, I want to do that, but I also want you to know how can you engage with NIST? Where can you find the opportunities? Who do you need to talk with, such that we provide as much benefit as possible? So I'm going to be talking about NIST and the Office of Advanced Manufacturing, giving an overview about them in the first maybe 10 minutes of the talk. And then I will spend the rest of the talk highlighting some selected activities that are taking place at the Office of Advanced Manufacturing. In particular, I will place much emphasis on the Manufacturing USA network, and I will talk about NIST's incoming role at with the Chips for America Act programs, to support a strong U.S. semiconductor industry. Then I will talk about our role in participating in the White House U.S. strategy for American leadership in advanced manufacturing. So with this, I will start with my first point, which is to talk about NIST. So I'm sure you have heard the word NIST before, but believe me, I have heard about it before. I've even heard about NIST before. I even worked with NIST before I joined it. And even though I worked with it and I had collaborators and I visited it and gave seminars on campus at NIST, there is still a lot to learn about it in terms of the background and mission that helps you, that is fascinating, number one. And number two, it really gives you a broader perspective of the agency and how you can you can engage better with it. So NIST is an agency under the U.S. Department of Commerce, and its mission is to promote U.S. innovation and industrial competitiveness by advancing measurement, science, standards, and technology. So this is our overall mission. Now, I'm not gonna preach to the choir over here. You are all working, or most of you are working on advanced manufacturing. So you are aware of the importance of measurement science. Measurement science provides the foundation for innovation in almost every industry and economic sector in the US and globally. And the role of measurement science is a federal role established in the US Constitution. In fact, the Constitution gave Congress the powers to set standards. In 1901, Congress created the National Bureau of Standards, NBS, which is the old name for NIST. And that was a bureau charged with developing and overseeing standards development. And in 1988, NBS changed its name to NIST and started to have a new emphasis on technology. So that's really a brief history of how and why NIST started, first as an NBS and then at NIST. Now, we do work in collaboration with US industry, with academia, and with other federal laboratories and agencies. And we also collaborate with our counterpart organizations around the globe. Just a few numbers to inspire you and to describe how impactful NIST is. We have a little more than 3,400 employees, 2,700 associates, and over the last 25 years, we have had 5 Nobel Prize winners from NIST scientists, and 2,800 publications just in fiscal year 2020. So you can see that NIST is a very impactful organization, and you'll learn more about it in the next few slides. So NIST has 2 main campuses, one campus in Gaithersburg, Maryland, and one campus in Boulder, Colorado. But in addition to these campuses, we have a number of joint institutes and centers across the country. I can spend an entire lecture talking about each of these institutes, but I will just highlight a couple of them in the next few slides. But the takeaway message over here is that NIST is not just Maryland and Colorado, it is spread out the entire nation. Our activities are divided into 2 broad categories. First, internal laboratory programs, and second, extramural industry assistance. So if we focus on internal laboratory programs, you see that we have lab programs. This is essentially where science is conducted. This is where research is being done within NIST. So we have our metrology labs that provide scientific research on materials and physical measurements. We have tech or technology laboratories that provide applied measurements and standards for communication, information, technology, and engineering systems. And we also have world-class user facilities that ensure the availability of specialized measurement capabilities to meet the needs of US researchers from industries, universities, and government agencies. For those of you who might be familiar with it, one example of this is the Neutron Research Facility. I have personally got to interact with that facility before I joined NIST as an additive manufacturing researcher at Texas A&M. And there's also the National Nanotechnology User Facility. So this is one important thing for you as an academic researcher to make use of. NIST has a number of programmatic priorities. I'm not going to go through all these in details. I just want to highlight that there are some of these priorities that are national priorities, that represent national priorities, labeled in orange over here. These include advanced manufacturing, cybersecurity, and disaster resilience. And then we have some other programmatic areas that are unique to NIST, not any other federal agency. We have documentary standards, technology transfer, which is a big focus at NIST, and measurement dissemination. Then, of course, there are some additional emerging trends. I'm sure you are familiar with all these buzzwords that NIST has a role one way or another, because these are upcoming trends that are going to shape the future of manufacturing in the nation and globally. So NIST scientists develop and deliver tools and technical assistance necessary to meet the needs of America's manufacturers. You can see some of the topic areas over here. Of course, the one closer to my heart is additive manufacturing, but the rest are very important as well. For example, NIST does support smart manufacturing through many programs such as robotics in manufacturing. And I know that Georgia Tech has a big robotics group and many very capable researchers in the field of robotics and robot-human interaction. The next generation of smart manufacturing processes and equipments are supported by some of the standards for robotics developed at NIST. And you can see that NIST has an advanced manufacturing funding level of close to 150 million just in fiscal year 2020. To further highlight the impact of NIST, one of our big roles with which we are very proud is NIST and disaster resilience. Essentially, NIST is authorized to investigate major building failures and through studies recommend changes to building codes and other standards. This helps avoid future tragedies. So, for example, we had very strong involvement with the World Trade Center tower collapse in 2001, with the Joplin tornado in 2011, even with Hurricane Harvey in 2017. In fact, recent investigations in Texas after Hurricane Harvey showed that the new construction built to codes informed by NIST technical recommendations significantly outperformed older housing constructions. So big impact over here. As far as standards are concerned, NIST role is very important. For example, NIST staff made significant contributions to robotics standards for safety and performance. By 2020, close to 40,000 collaborative robots working alongside humans in factory environments are enabled by standards that NIST helped to develop. And finally, to wrap up my overview of NIST, NIST has a very strong emphasis on tech transfer. And you know, tech transfer is something that is not straightforward. There's always lab research, whether it's basic or applied research. And then there's commercialization and scaling up and making actual use of intellectual property. And this process of tech transfer is a very challenging task, and many countries, not the US alone, have agencies, government or non-government, that are focused on this. And NIST has a very strong emphasis on tech transfer, as you will see in the remainder of this presentation. So with this quick overview of NIST, let me zoom in a little bit and talk about NIST's Office of Advanced Manufacturing. What is it? Because when I first joined, in my first few days, my colleagues from Texas A&M and other universities would ask me, so what exactly is NIST Office of Advanced Manufacturing? We know NSF, we know AFRL, we know AFOSR, but what does OEM do exactly? It has actually a very serious role. So OEM, I'm going to call it OEM for the remainder of the presentation. OEM is essentially it's an interagency team building partnerships with US industry and academia. It manages NIST outreach in the area of advanced manufacturing and serves at the headquarters for what we call the Advanced Manufacturing National Program Office. And this office works in close partnership with Advanced Manufacturing Office across agencies, DOD, DOE, NASA, NSF, Department of Education, and Department of Agriculture. So essentially, almost all work that is related to advanced manufacturing that happens over the federal government the Office of Advanced Manufacturing has one role or another, and usually this role is to coordinate these efforts. So we have very strong presence in the advanced manufacturing scene in the US. And then, like I described, internal programs at NIST labs where the research happens, there are also external programs or extramural programs. And these are primarily managed and coordinated by OEM. I mentioned from them the MEP or Manufacturing Extension Partnership, which focuses on helping small and medium manufacturers. These are centers that exist in all of the 50 states in the US and Puerto Rico. And there is, of course, Manufacturing USA that is going to be the next portion of the presentation. And there is the Baldrige Performance Excellence Program, which sets the standard for organizational quality. And many organizations in the US and worldwide make use of these standards developed by the Baldrige Performance Excellence Program. But for the sake of today, since we do not have, or my assumption is that we don't have as many small and medium enterprises in the audience, and I'm going to be focusing on Manufacturing USA. So in fact, for the remainder of the presentation, I will be focusing on three major activities that I want to highlight today that happen within OAM, Office of Advanced Manufacturing. The first one is Manufacturing USA, and then I'm going to talk about the CHIPS Act and the White House's Strategic Leadership Program. So I'll start with Manufacturing USA. And I'm sure that many of you have heard about Manufacturing USA. I'm sure that many of you even have grants from Manufacturing USA institutes. But again, I'm going to re-emphasize a point that I said at the beginning of my talk. I was the same. I actually was a member within Texas A&M of the satellite campus of America Makes, which is the first Manufacturing USA institutes. So I liked to believe that I knew enough about Manufacturing USA. Turns out, Manufacturing USA has much more to offer than what we as academic faculty members typically know. And this is one of the things that I want to highlight today. That Manufacturing USA, there are opportunities to engage with it that sometimes we oversee or we overlook. So the Manufacturing USA network secures US global leadership in advanced manufacturing. That is the big motto that we have. And the mission is to connect people, ideas, and technology to solve industry relevance challenges, to enhance industrial competitiveness, and strengthen our national security. But why did we need Manufacturing USA? Because, again, a lot of people, not even technical people, many people that just heard about it would say, why do we even have Manufacturing USA? What is Manufacturing USA? So the stimulus for the program was the collapse of so much of the US industry in the early 2000s. Essentially, we lost 1/3 of our workers in the first 10 years of 2000. And we, for the first time in 2 centuries, our advanced technology products trade balance became negative. This is a clear failure of the market to maintain our economy, and thus the role of the federal government to step in. But of course, sometimes it takes a while for our system to recognize a problem and then take action. The Manufacturing USA program was not authorized by Congress until 2014. So what is the purpose of Manufacturing USA? The US is great in innovation. In fact, the US leads world in innovation and inventions. But we struggle a little bit in transferring this innovation to the market to support manufacturing. And I'm sure that many, if not all of you, are familiar with the famous technology Valley of Depth. So the Manufacturing USA focus is to de-risk promising new technologies and to address market failure in pre-competitive manufacturing R&D. In particular, focus is on technology readiness level ranging from 3 or 4 and up to technology readiness 7. This is what we call pre-competitive manufacturing R&D. Of course, TRL or MRL 1 and 2 are more related to basic fundamental research. This is what we do in universities. And Manufacturing USA really fills this gap. How does it fill this gap? It fills it through what we call public-private institutes or partnerships, public-private partnerships. So essentially, the institutes are industry-led consortia, and they are designed as public-private partnerships, and these provide effective collaboration space for pre-competitive applied R&D, solving big challenges. You would find that each Manufacturing USA institute is a consortium of industry, academia, and government research labs over here. And what this is trying to do is to provide provide a neutral collaborative space for all these stakeholders to transfer lab research from lab to market. Since 2014, we have established 16 manufacturing innovation institutes. You can see a map with these institutes over here with their names. They are all in distinct technology. They all have distinct technology focus. And you can see from the map legend that there are a lot of educational institutes, industry members, and government, and even nonprofits that are members of the overall network. And this is another representation of the Manufacturing USA institutes with categorized by focus, from electronics to materials, all the way to digital and automation. And this is a list of the partner agencies. These you might be familiar with. I'm sure many of you as academic researchers are familiar with NASA and with the National Science Foundation and with other federal agencies over here. And the Manufacturing USA and the Advanced Manufacturing National Program Office brings those together into the Manufacturing USA network. And what is the benefit of the Manufacturing USA institutes? Well, the institutes decrease the cost of experimentation for members by providing access to cost-prohibitive equipment and pooling R&D dollars. So I'll talk about what I know, what my technical expertise is in. Metal additive manufacturing. You know, a reasonably good metal additive manufacturing system would cost anywhere in the ballpark from maybe 400 for a basic, all the way up to 400K up to 1.5 million. Not all research groups have access to such equipment. You can generalize this example to other topics and thrust areas. So can we provide access to such cost-prohibitive equipment to boost the research environment? The Manufacturing USA network has demonstrated potential to deliver 5-fold increase in leverage value for members. And it gives members access not only to government funding and partner funding, but also to broader IP portfolios and R&D. Because when you are a member in an institute, of course, depending on which institute and on your membership tier, you get access not only to their members, not only to their equipment and test beds, but also to the IP portfolios and research and development. So getting involved with Manufacturing USA Institute carries more weight and value than some think. Just to highlight some of the Manufacturing USA impacts, and these are all taken from the annual highlights report. And by the way, each year we publish 2 reports for the Manufacturing USA network. We publish one general publicly available highlights report for people to go through it and see what each of the 16 institutes is doing and how they achieved impact. And we publish a report to Congress. This report to Congress essentially justifies the funding that we receive, how it was utilized, and what return on investment was provided. So from this highlights report, which is publicly available, you just go really to Google and type Manufacturing USA Annual Highlights Report, and you will get it as one of the first few hits. We have had 500 major R&D projects, about 400 million spent in private and federal funds towards applied R&D, and a big focus on education and work development as well, because this is a gap that we are all familiar with. Up to 70,000 participants in advanced manufacturing workforce development and training have benefited from the Manufacturing USA network. Another very important role that Manufacturing USA proved worthy was, of course, during the pandemic. I don't mean to repeat cliches, but COVID-19 did hit with a speed and force that commanded the best in government, academia, and industry together at an unprecedented pace and accelerate innovations to address the needs of the nation. And indeed, Manufacturing USA Institute did conduct assessment and did conduct a bunch of very inspiring projects, ranging from 3D printing of personal protective equipment using American Makes facilities to projects related to robotics at the ARM Institute to facilitate testing processes of COVID tests, to antigen testing at the Department of Commerce funded institute called Nimble in Delaware. So Manufacturing USA Institute, I actually had a few slides about specific projects that I was planning to highlight, but then I thought I would keep them to the backup and only describe them if I have time, because there are other points that I want to hit before I wrap up the talk. But just the takeaway message over here is that Manufacturing USA Network contributed 36 manufacturing innovation rapid response projects to combat COVID-19. And this was also along with $73 million in COVID aid relief and economic security, what we know as the CARES Act. So I encourage you to take a look at this report as well. It's also publicly available, and you can easily find it present online. Okay, so this is great. Now, how can we get involved? This is all great. We believe you. We believe that Manufacturing USA is important. We believe in the importance of tech transfer from lab to market. We believe in the importance of education and workforce development on the national level. But we're faculty members. I know NSF. In NSF, it's very clear. I go and submit a proposal to a solicitation, whether a general solicitation or programs like the NRT or the ERC or the career programs. It's very clear. There's a clear path. But I personally, and I'm citing my own story over here, I personally struggle to know how I can engage with Manufacturing USA. That is a question that is often raised by some of my fellow faculty members. And in fact, right now, I have brought it to my office's attention that maybe we need to spend more effort in engaging faculty members more than how they are already involved. Please notice, I'm not saying that faculty members are not involved with Manufacturing USA. I'll prove actually the exact opposite on the next slide. But what I'm saying over here is that I'm trying to work with my office on highlighting and emphasizing pathways for faculty members to get more effectively engaged with Manufacturing USA, because sometimes we know about it from a colleague or our department or institution happens to be active with Manufacturing USA, but that's not the case in all academic institutions in the US. So I think we need to do that. But if you are wondering how you can get involved, first of all, let me highlight that 23% of members of the Manufacturing USA network are community colleges and universities. So 1/4 of the members, that's a big base in the membership, in the overall membership. So there are a lot of academic institutions that are engaged. This is a good data point to show you that there's relevance of Manufacturing USA not only to the prosperity and national security of the nation, but also to academic research. The first step you need to do is to identify the Manufacturing USA Institute that best aligns with your interest and expertise, because there are 16 of them, and they do cross-cutting work. So sometimes, someone like me who works in additive manufacturing, do I want to get involved with America Makes, or maybe I'm more interested in the lightweighting aspect of additive manufacturing, so I go and engage with Lift, or maybe I'm more interested in the digital aspect of additive manufacturing, so I get involved with MXD. So first of all, take some time to go through the 16 institutes and understand their scopes and identify 1 to 3 institutes with which that best align with your interests. That's step number 1. Step number 2, figure out if you're a member. I can't tell you how many people I have met in academic institutions that were pleasantly surprised, that their university is a member of a specific institute that's of interest to them. So in fact, one of them was my colleague at Texas A&M, and say, oh, if only we were members at America Makes. And I told him, we are members at America Makes, we just don't know it. So after you identify institutes that are of interest to you, go and check. Chances are, Georgia Tech is a member in many of these institutes. So maybe you already are members, and maybe you already have access to all their resources, but you don't know about it. So these are 2, I know, seemingly naive steps, but believe me, they happen in reality and they are important. And then do attend technical exchange meetings. These are publicly, most of the time, they are available for non-members, sometimes not, it depends on the institute. And also, these institutes issue project calls, just like how NSF issues solicitations, just like how the Department of Defense issues BAAs. Manufacturing USA institutes issue project calls for funding, and they have info sessions for these calls. And oftentimes people are not even aware of the existence of these info sessions. So make sure to be following the institute of interest to you, and making sure that you engage with the sessions and with the webinars that talk about these solicitations, so you can make use of them. Now, often these solicitations are team-based. Like, you don't just go there and apply as a single faculty member. You go as a representative of your university, and you have a team of members from within the institute. So if a project call is out today, probably the deadline is going to be in some time between 4 to 8 weeks, which is not enough time to gather a team. That's why it's important for you to be ready with a team. So you need to be involved and engaged with institute activities, just for the sake of building or pre-building your team, such that when such calls are issued, then you are ready to address them. Because that's one thing that happens all the time. Hey, America Makes had this great project call on qualification and certification of metal additive manufacturing parts. Oh, I know qualification and certification. I know it very well. This is my research focus. I should target this call. But this call, encourages a team that has one material vendor and one end user and maybe a community college. And you definitely don't have time over 4 weeks to build such a team. So you need to be ready with this. And by the way, oftentimes, these project calls, there are some precursors to them. So if you are engaged with the institute, you will hear about the potential of these calls coming out soon, so that you can start preparing. So communicate with members and prepare for opportunities. This is the key for faculty members to succeed with Manufacturing USA. And make use of institutions' resources. Many of them have portals that have documentation. Many of them have, you get access to the intellectual property that is developed as part of Manufacturing USA projects. You get access to experimental test beds. Maybe you want to measure residual stress on a component, and you just don't have the facility at hand. So please make use of these facilities, and most important of all, reach out to us. Reach out to me, reach out to anyone in my office, reach out to anyone at NIST to get clear guidance on how you can maximize your benefit as a faculty member from Manufacturing USA. Manufacturing USA has not been created as just a checkbox or to fill in some needs and fill some requirements. They are truly established with their mission in hand, and there are a lot of opportunities for faculty members to get engaged. I hope this serves to inspire you to the importance of Manufacturing USA. I know that the previous seminar was from one of the institutes, if I recall correctly. So I'm sure what I'm saying right now has been said before, but I mean to emphasize it from my position as your fellow faculty member, if you will. Okay, so enough about Advanced Manufacturing USA institutes, and let me move on to my next topic, which is Chips for America Act. We have a manufacturing problem in semiconductors. You know that very well. We are still global leaders in semiconductor design. You know how our iPhones, for example, as just one example, are designed in California and manufactured elsewhere. So we are global leaders in semiconductor design, but we have fallen, our share in global share in manufacturing has fallen from 40% in 1990 to 12% today. And even worse, what we call semiconductor packaging, and I don't claim to be an expert in semiconductor manufacturing, by the way. I know some, and I'm learning more. But for packaging, which it's a big emerging field, our global share is just 3%. And this is very, very serious. So to respond to this, the Chips for America Act has been passed as an authorization as part of the National Defense Authorization in 2021. Many people don't understand what the CHIPS Act and what NDAA are, and I didn't before I joined NIST. This passed as an authorization. Authorization means that you as an agency are allowed or permitted to do the work, but you didn't get the resources or the funding yet to do it. So you have the permission, but not the funding or the resource. This is what we call an unfunded mandate. Fortunately, recently, the request for funding, or what we call appropriation for the CHIPS program, has passed both the House, called USICA, and the Senate, which you might know as the Competes Act, and now it's in conference. So it is on its way, hopefully, to become a law. And when it becomes a law, this is what is going to happen. We, at the Department of Commerce, there's going to be $52 billion total budget over 5 years. $39 billion are dedicated to financial incentive programs. This is basically for industry to improve semiconductor fabrication and address the severe chip shortage that we have now in the US. And $11 billion will be dedicated to R&D. This is when our ears perk as academics. $11 billion will be dedicated to research and development to prepare the nation for leadership in the world of semiconductor and packaging and the entire supply chain. In addition, there is a strong workforce component in both the financial incentives and the R&D programs. So if you are interested in the very big area of semiconductor manufacturing, or you know some about advanced packaging, or you are interested, or you have a passion like Dr. Brown for workforce development, there is going to be a lot of opportunities that are coming your way. But the programs shown here are the ones that are being administered by the Department of Commerce and by our office at NIST. But there are additional programs, for example, at DoD that I don't, and at NSF that I don't mention in this presentation. There are currently 10 institutes in the Manufacturing USA network that conduct work related one way or another to semiconductors. But one of the 4 big areas of the CHIPS Act, or the programs of CHIPS Act, is to establish a new Manufacturing USA institute targeting semiconductors. So the 4th R&D section of the CHIPS Act is to stand up a Manufacturing USA Institute, or possibly more than one, actually. It might be one, it might be more than one, focused on semiconductors and advanced packaging. We'll make sure not to duplicate current efforts. It will be much larger in scales, probably, than existing Manufacturing USA Institutes, but there is a lot coming. So the money that is dedicated to R&D, that's going to go to fund basic research, to fund applied research, to fund educational workforce development, to establish user facilities, to establish a new institute. So many things will be done with this. If you ask me in the question, hey, have you determined what are you going to do with this? The answer is no. And that is precisely why we are currently running a request for information to where we can receive information to inform CHIPS Act program design. So just like you have provided input for the strategic plan of the US, we also invite you to participate in one of these RFIs on that we are using to plan what is how the funds from the CHIPS Act funding will be allocated and what exactly will be done with them. We are also coordinating with other federal agencies. We are coordinating with NSF. We are coordinating with NASA. It's a big initiative, and all agencies and all stakeholders in the semiconductor world in the US have to work together on this. So with this, I'm going to spend the last 3 minutes of my presentation talking about a very important role that we coordinate and manage, that we coordinate at the Office of Advanced Manufacturing, which is the White House Strategy for American Leadership in Advanced Manufacturing. So essentially, there's something called the National Science and Technology Council, NSTC, and that's a cabinet level council. And under that council, there's a subcommittee on advanced manufacturing, SAM. It originates back to a congressional mandate in 2012. It was truly bipartisan act, and its function is to do interagency planning, coordination, information sharing, and the development and execution of national strategic plan for advanced manufacturing. Essentially, this is a document issued by the White House Office of Science and Technology Policy, OSTP, and it lists what are the current priorities and the priorities for the next 4 years that both the community but also the federal government should be focused on in developing its program. For example, the 2018-2022 version of this strategic plan, which was published, had 3 goals that were focused on manufacturing technologies, workforce education and workforce development, and supply chain. And right now, we are working on updating this 2018-2022 Advanced Manufacturing Strategic Plan. And in doing so, we have conducted a series of stakeholder outreach. We have issued an RFI very similar to the one that I just mentioned related to semiconductor, to the CHIPS Act. It was published in October in 2021, and we have conducted a series of 14 in-person and virtual sessions at many events. You might have participated in one of them. We engaged with several technical societies. We had 600 plus participants and 700 plus input received, and we have worked in my office on compiling all this input and then working with an interagency writing team from the 9 federal agencies to put together this update of the report. So the current state of affairs is that we have finished all the public sessions, we have collected input from all stakeholders, and we just got done with analyzing all this input about 3 weeks ago. And over the last 3 weeks, we have spent them on synthesizing this input into one single report in collaboration with all the agencies. Now, you can only imagine how challenging of a task it is to compile input from this number of stakeholders. Oftentimes I even had to sit down and analyze chat sessions from one of the virtual events and extract useful information from it. But at the end, we succeeded. I think we have reflected. We have come up with a document that is very representative of the input that was received. And right now, we are working on finishing up the first draft. The goal is to submit it to the White House early enough, such that we meet the strategic plan release, which is National Manufacturing Day in October 2022. And when this is out, I encourage you to take a look at this report, to make it guide your, maybe not your immediate research tasks that are already ongoing, but to guide you in, you know how we always put our 1 year and 5 year and 10-year research plans. Make sure to make use of this, because the federal government agencies are going to be looking into this report in putting together their own funding program. So this is how it's relevant to you as a faculty member. So, use it in your proposals. use it, in your papers when you can, to make strong arguments that, hey, this research that I'm doing, the scope of the current manuscript is aligned with the priority of the US administration to achieve its global leadership in advanced manufacturing. So with this, I'm going to wrap up with some concluding thoughts. There is a plethora of opportunities to engage with NIST OEM and Manufacturing USA in general, and faculty members often miss those. For example, I'm listing here 2 funding opportunities that came out last year. Maybe some of you made use of them, maybe not, but I personally did not know about them because I was not following closely enough. There was, the Rapid Assistance for Coronavirus Economic Response Grant Program, RACER. This was a series of grants that was meant for COVID response. And then there is the Manufacturing USA Technology Roadmap with manufacturing tech grants, which were $300,000 planning grants for project leaders to develop roadmaps of new technologies. This one is still under review, but it is scheduled to, the awards are, I think we just finished the internal review process, and they are scheduled, the awards, to be announced sometime in the next few weeks or so. So there is a plethora of opportunities, but equally importantly, there will be more opportunities in the very near future, especially, but not limited to, semiconductor manufacturing. So please don't think that I'm just promoting semiconductor manufacturing here. I work in additive manufacturing. I have vested interest in it, and there are opportunities in additive manufacturing. In fact, there is a document that is parallel to the strategic report of the White House that talks just about additive manufacturing. So there are existing opportunities, future opportunities, many of them in semiconductor, but many of them in other fields as well. So please connect with NIST Labs, OEM, and Manufacturing USA to plan for and make use of opportunities when they arise. And with this, I thank you for your attention, and I open it up for discussions or questions. Thank you very much.
Thank you so much, Dr. Elwany. Your presentation was packed with so much useful information, and we appreciate the tips that you provide along the way too, and in the different areas that you covered. Thank you for the overview of NIST. I think it's important for us to understand the role that NIST plays in advancing the manufacturing industry overall through technology standards and the research you're doing in collaboration with institutes such as ours and industry. The Manufacturing USA overview was very good and useful, I think, for those members of our audience who may be less familiar. And to our audience members who are from Georgia Tech, I would just remind you that Georgia Tech is a member of many of the Manufacturing USA Institutes, or MIIs. So in total, we're a member of 11 of the 16 MIIs. So there's a good chance we have an MII in your area of interest if there's one that you'd like to get more involved in. So please reach out. You can certainly reach out to me, Ph.D, or and I can help put you in touch with the right point of contact internally for that MII. Thank you also for the CHIPS Act overview, advancing the semiconductor industry. Obviously, that's a very hot topic right now and very important. And then, of course, the National Strategic Plan for Advanced Manufacturing, and Georgia Tech did submit a collective response to the RFI on that, and we appreciate that opportunity. So I would encourage our audience members to go ahead and submit any questions you have through the Q&A panel for Dr. Elwany, and we still have roughly 5 minutes or so remaining to address any questions. But while we wait for those to come in, Dr. Elwany, I was curious if you can talk about, early in your presentation, you outlined the NIST Programmatic Priorities, and then, how the work falls under those areas. I was curious if you can comment on how those priorities are determined or maybe even adjusted over time as the world changes or manufacturing needs change.
Yeah, okay, so let me get my pointer back. Yeah, these priorities, of course, it's a living document, right? Like where we start with something, but they are always driven by national needs. So we review all sorts of reports and documents that come out of the administration. We see what the national priorities are, and we make sure that our programmatic priorities are aligned with these. In doing so, we don't just read the National Strategic Report that I referred to. There is a report by the White House on critical emerging technology. There's a report by two reports by the White House recently on supply chain resilience. So we refer to these reports, and also from our communication and coordination with other agencies, we set our programmatic priorities primarily to address national needs. And the second thing, of course, is we maintain what we are known for and what's unique to us. Standards, we are the go-to entity in the federal government for standards and for tech transfer through the Manufacturing USA and measurement dissemination. So these are pretty much fixed over here. They are part of our mission. And then these are what keep changing all the time depending on new trends and new topics. So we do have internal meetings that we call VCAT meeting. I apologize, I even forgot what it stands for. It's like considered the NIST State of the Union address. We have this multiple times a year, and these meetings are what guide us in reviewing our programmatic priorities. So it's an all stakeholders discussion that involves the labs, the business offices, and everyone at NIST in collaboration with guided by federal government priorities. I hope this answered the question, Paige.
Thank you very much. That was helpful to me. Hopefully it was helpful to our audience as well. And we appreciate the transparency. And I think it's nice to know that, I think some of our input may feed into that, in terms of the National Strategic Plan for Advanced Manufacturing. It sounds like that's part of helping to determine one of the resources you look to determine those priorities. I had one other question, then I want to go to the audience members' question. That is, if there are researchers out there who are interested in engaging with NIST or one of the MIIs, is it best that they do that through their institute, or is there a way for them to directly engage as an individual?
Through their institutes, like their university, where they work? Okay, the best thing, what we recommend is you as a faculty member, you are a member of the institute because your organization is. So you reach out to the Manufacturing USA Institute of Interest. You go to their website, find the key personnel there, and reach out to them. So I would recommend you do this as a standalone faculty, but representing your university, of course. So that's your first stop. Second, if for any reason you send an email and you get no response, you will get responses, but in the unlikely event that you don't, then you contact us, the Office of the Advanced Manufacturing National Program Office. We have quick and easy access to all these Manufacturing USA institutes, and we'll put you in touch with the right people. In fact, you can also, if you are not sure who to contact, if you are just saying, hey, I am faculty member X who works in, I'm just going to say any focus on photonics. I don't even know who to contact or which institute does more work than others. I read the report and they all seem to do work there. I'm confused. What can I do? You contact the Advanced Manufacturing National Program Office. There is an email listed on our website. This email, I assure you, is being monitored and read and responded to. So my short answer, a very long answer to a short question, but start with contacting the Manufacturing USA Institute key personnel yourself. Second, if you are not sure how to do that or who to contact, reach out to the Advanced Manufacturing National Program Office, and we'll be happy to help. We've helped multiple people in the past, and we're continuing to do that.
Thank you very much. Appreciate it. And we have a question from an audience member. That is, are there opportunities for funding small businesses?
Yes, absolutely. And this comes both through Manufacturing USA project calls, but also through the MEP. And I'm sorry, I did not go much through the MEP program, but if your interest is more in funding for small and medium enterprise, I would definitely start engaging with the MEP program. And again, just like what I said to Manufacturing USA, if you are not sure how to get engaged with MEP, you let us know. First, identify the MEP center in your state. Each state has one center. To reach out to your local state MEP center, they will help you. They want to help. And if you fail to reach someone that answers to address your inquiry, reach out to us and we'll put you in touch with the right people. We'll even educate you about it and tell you how exactly you can make use of it based on your need. But yes, there are funding opportunities. Also, always be on the lookout for the Economic Development Association, EDA. That's another agency under the Department of Commerce. These have tons of opportunities for funding small and medium enterprises as well.
Thank you so much for that thorough response. And to our audience member who asked that, so Georgia Tech does have a manufacturing extension partnership office on site. So I'd be happy to talk offline with the person who asked that, and maybe we can get you connected there. So thank you very much for the advice. It looks like we're at the end of the hour, just over by about a minute. Dr. Elwany, thank you so much for your time and the wonderful information that you shared today. And thank you to our audience members who joined us. And I would encourage our audience members to tune in again next Monday at noon. We will have our next Lunch and Learn speaker will be from industry, Connor Spiegelman and Allison Borrow. We actually have two speakers from Carbon Inc., and they'll be discussing exploring 3DP and production with DLS technology. Thank you, everyone. Have a great afternoon.
Thank you, Paige, and thank everyone for attending, and thanks for GTMI for inviting me. Have a good rest of your day.
You're welcome. Thank you.